Today we are talking about simplifying complex fractions. Here are some instructions. You can do it this way, but I have a way that I feel is easier than this. Okay, write this down, please. First step, find the LCD. Who knows what LCD stands for?
Least common denominator.
Correct. Least common denominator of the entire problem. Okay. Step 2. Multiply every term. Good. By the LCD. Least common denominator.
Step 3. Simplify.
Good. And step 3 is simplify.
Maybe have to factor.
You may have to factor, exactly. Okay, so on example 1,
Multiply by 5.
the least common denominator in this problem is 5. So next to every single term, I am writing 5.
Over 1?
You can put over 1 if you want. I'm just going to write 5 because it saves me a little time. So I'm multiplying every single term by 5. What happens on the top with that first?
That would become
The whole purpose is that you're going to get rid of some of these fractions, okay? So these 5's cancel, and I am just left with x on the top. Now I'm going to the denominator. On that first term, the 5's cancel out, and I am just left with,
X plus 5x squared.
good, x. And then I have plus. There's nothing to cancel there, and so we multiply it together, and I have 5x squared. Now, so we took care of step 1 and step 2. Step 3 is to simplify. Oftentimes when we're simplifying, we're going to have to end up factoring. Is there something that I can factor here in the denominator?
X.
Good, I can take out an x. So we take out the x, you're dividing each of these terms by x. What is x divided by x?
X.
1 plus, and then here an x cancels with 1 there, and we're left with
So it would be 5x.
5x. On top, my numerator, I still have x there.
So then you would cancel it.
So now I'm just going to reduce. The x's cancel out. If there is nothing left on top, what's actually there?
1.
A 1. So my answer is 1 over 1 plus 5x. Can I cancel out these 1s?
No.
One's in the parentheses.
Good. It's connected to that 5x. Think of them as like connected with glue. You can't cancel these out unless you have a whole thing that is the same. Whenever you have pluses and minuses, everything has to be exactly the same. Okay, questions there? All right, example 2. Okay, so looking at this problem, what would be my LCD?
3x.
Good, because we have a 3 in one denominator and we have an x in one denominator, so you're going to need both of them. So my LCD of the entire problem is 3x. Once you figure out what the
How do you know
so you always look at your denominator. So you have a 3 there, and then in the denominator over here I have an x. They don't have anything in common, so if they don't have anything in common, you would like multiply them together. If like this was a 3 and this was a 6, it has to always be at least as big as the biggest number. So 3 goes into 6, then 6 is my denominator. Does that kind of make sense? All right. So once you figure that out, we are going to do what? Good. Go to every single term, and you're multiplying each term by 3x. Each term is separated like by the pluses and the minuses.
This is pretty easy.
So on my first term there, what happens?
You get x squared minus.
Good. My 3's cancel out. Okay, and I'm left with x times x, which makes x squared. Minus. Can I cancel anything out here? No, because there's no denominator. So you're just multiplying that together. 3x times 6 is 18x. Good. Now we go to the denominator here. What is going to happen with the 3x and the 10? Which makes
30x.
plus, and then here the x's cancel out, and I have 3 times 4, which is 12. Okay, so on the top, can I factor that at all?
Okay.
Good. I can take out an x, and I'm left with what? X minus 18 is correct, because we're dividing each of these terms by x. In my denominator, do I have a GCF? A 6. Very good. Which means I'm dividing each of these terms by 6, and what am I left with? 5x plus 2. Can I reduce anything here? No. So this is my answer. Are there any questions? So if you can't reduce anything, you just leave it in factored form. Okay?
Or what if it was, what if it was like x minus 4 and you can make x minus 2x plus 2? Would you write it like that, or would you just keep it like x minus 2?
No, if you could factor it further, you'd factor it further. Okay? All right. Example 3. What is my GCF on this problem? Y, or, sorry, not GCF, LCD. My LCD is y. My least common denominator is y. So we go to every term, and we're going to write times y. On my first one, y times 1 is just y. Plus, my next term, what happens? So I just have a 1. My denominator, and you write these in alphabetical order. So when you have y times x, you actually are going to write that as xy. Plus, here my y's cancel, and I just have an x. I can't factor anything out of the top, so I just have y plus 1. Can I factor anything out of the denominator? So we take out an x, we divide each of these terms by x, and we end up with y plus 1. Good. And y plus 1s, those can be reduced, correct? So we cancel those out. If nothing's on the top, what's actually there? 1 over x. Okay. I'm going to give you a chance to try example 4 on your own. But before you do that, yes. Very good question. What do you think the LCD is on this? It has to be at least as big as the biggest number. Because if I multiplied by 6 here, then I'd still have a fraction, wouldn't I? Because the 6 would reduce with the 36, but you would still have a 6 in the denominator here. So 36 is your LCD. Remember that it's going to always be at least as big as your biggest number, although it could be bigger. So I'll give you a couple minutes to try this one on your own. And when you get your answer, you could write it on a whiteboard, or you can show me, and I will check your answer.
Hey, no, I have mine.
Yeah.
Mine.
Yes.
It's
Yes. Oh my gosh.
oh, it's a difference of square. So 6x plus 6x minus 6 over 6x minus 6.
All right, so here we go. The LCD is 36. The correct answer was 6 over 6x minus 1. So I'm multiplying every single term by 36. When I do that, nothing cancels here, so I have 36 times x, which is 36x. Next, 6 goes into 36 6 times, and so I have 6 times 1, which is 6. Divided by, we have 36x squared. I have to multiply those together. Here the 36 cancel out, and you have minus 1. On the top, what can I factor out? A 6, and I'm left with 6x plus 1 because I'm dividing each of those terms by 6. In my denominator, these can all be written as squares. 36 is 6 squared, x squared, and then 1 can always be written as a 1 squared. So this is a difference of squares. We get 6x minus 1 and 6x plus 1. So we can cancel the 6x plus 1s, and we're left with 6 over 6x minus 1. And that is my answer. Any questions? Yes?
Like, like the 36, how there's 36 on the top and the bottom. Why couldn't you just, cross those out?
Good. Why can't I cross out these 36x, these 36s?
Because one has an x squared.
This has an x, this has an x squared. Also, whenever you're connected with pluses or minuses, you can't cancel them out unless you can cancel out the whole set. Okay? So since we can't cancel out 36x plus 6, we're going to factor to see if we can end up making a whole set the same. So pluses and minuses connect, and you can't cancel out individual things. Only the whole set. Any questions? Other questions? All right. Thank you.